Alright, so before we get started, we have to go back and recall the values from our chart. So what I want you to do is I want you to pause this. I want you to fill it in by yourself, and then I want you to go back and check what you have with what I complete. And these are the values that you should have come up with. Alright, but what I want you to draw your attention to is when you look at 30, 45, and 60, all of that comes from the first quadrant. But we have more than just one quadrant in our coordinate plane. We have 4 quadrants. Alright, now 30, 45, and 60 represent reference angles. So 30, 45, and 60 are just 30, 45, and 60 in the first quadrant. But in the second quadrant, the way I found my reference angle is I did 180 minus theta. When I was in the third quadrant, to find my reference angle, I had to do theta minus 180. And then in the fourth quadrant, I had to do 360 minus theta. All of those gave me my reference angles. So all of these values right here for 35, 45, and 60 all work not only in the first quadrant, but also in the second, third, and fourth quadrant, depending on what this reference angle actually referred to in those quadrants. So for example, if I'm looking at my reference angle of 30 degrees, all right, let's look at 30 degrees in each quadrant. So that means in quadrant 2, 30 degrees, which is my reference angle, 30 degrees equals 180 minus theta if I want to figure out what that original angle was. So that means I have to subtract 180 on both sides. So I get negative 150 equals negative theta. All right, but here this negative and this negative both change to a positive if I want to get a positive theta. So theta equals 150. So that means in quadrant 2, 30 degrees was a reference angle for 150 because 180 minus 50 gives me 30. All right, well, let's look at if I was in quadrant 3, what was the actual value? Well, again, my reference angle that I'm working with is 30 degrees. So 30 degrees equals theta minus 180. And if I want to solve for what this actual angle value is, I have to add 180 to both sides. And I get 210 equals theta. So that means in quadrant 3, my actual angle value is 210 for the reference angle of 30 because 210 minus 180 equals 30 degrees. All right, if I go and I work in quadrant 4, so in quadrant 4, again, I'm working with my reference angle of 30 degrees. So I'm going to say 30 degrees equals 360 minus theta, because I want to know what was that original theta value. So minus 360 on both sides, and I get negative 330 equals negative theta, but this negative and this negative can both change to a positive, so theta equals 330 degrees. So that means that 30 degrees is a reference angle for 330 in quadrant 4. All right, I could keep going with this pattern here to figure out 45 and 60. All right, or I can go with, all right, if I was looking at 45 degrees in the second quadrant, 180 minus what gives me 45 degrees, and that's 135 degrees. So we can do a lot less work on this. All right, if I was in the third quadrant, what minus 180 gives me 45, and that is 225. All right, looking in quadrant 4 with 45 degrees, 360 minus what gives me 45 degrees, and that is 315 degrees. All right, now I'm going to look at the same thing for 60 degrees as my reference angle. So for 60 degrees in the second quadrant, I want to know 180 minus what gives me 60, and that's 120. In quadrant 3, what minus 180 is going to give me 60. that is 240 degrees. And then in quadrant 4, 360 minus what gives me 60, and that is 300 degrees. All right, so now these are all of my actual angle values in each quadrant given my reference angles, because we're going to need to use these when we go in and solve trig equations. Alright, but before we go in and solve anything, I just want to briefly recall when we graphed sine, cosine, and tangent functions. So when there was absolutely no transformation of my sine and cosine functions, so the period didn't change, the amplitude didn't change, there was no phase shift, there was no vertical displacement. When we were just graphing a normal sine and cosine curve, we always went with a period of negative 360 to positive 360. So here, if you recall, this red curve is my sine curve, and this green curve is my cosine curve. Alright, but when we did tangent, our period changed from negative 180 to positive 180 when we graphed it. And we want to keep these things in mind for when we go in and when we solve trig functions. Alright, so let's take a look at solving trig equations. Alright, just like when you solve equations that don't have sine, cosine, or tangent in it, your point is you want to get this variable by itself. That is my goal. Alright, so that means right here I have to separate this sine from this x value. And if you remember, in order to separate these two things, I don't divide by sine. You can't do that. What you do to separate sine and x is you must use inverse trig. So one of your final steps is always going to be to do inverse trig. So right here, in order to get x by itself, x is equal to the inverse sine of 1/2. Alright, so when you get to this point right here, when x is all by itself, you have sine inverse 1/2. So what I want to know is, where does sine equal 1/2? This is where you have to look at your chart values. If you look at where sine equals 1/2, sine equals 1/2 at 30 degrees. Okay, but this is not going to be my only answer, because this wants to know where sine is a positive 1/2. Alright, so 30 degrees was my reference angle. So we want to take a look at a smart trig class. Alright, because sine is positive in the first quadrant, sine is also positive in the second quadrant. So that means 30 degrees was my quadrant 1 value, but if you look at quadrant 2, 30 degrees was a reference angle for 150 degrees. So that means that sine also equals 1/2 at 150 degrees. So these are my two first answers. Alright, but we would be done here if we weren't looking at a domain that goes on forever, because I want to look at forever, when does sine equal 1/2. So it's not just 30 and it's not just 150. Alright, but our period was going from negative 360 to positive 360. So that means what I have to do is, with my first answer of 30 plus or minus 360n, where n just represents any number. It could be 0, it could be 1, it could be 2, it could be 3. But this just gives me all of my possible values for where sine is 1/2. Alright, then I take my second answer, which was 150, and I do the exact same thing. That 150 plus or minus 360n would give me a sine value equaling 1/2. So this right here is my final answer. These are all of my possible values. Alright, let's take a look at another one. Let's look at this one. Solve the trig equation 2 tangent squared x minus 2 equals 0. Alright, well, again, just like if I was solving an equation, this is what I want to get by itself. If I was solving an equation here, first thing I have to get rid of is this plus or minus. So that means I'm going to add 2 to both sides. So I have 2 tangent squared x equals 2. Alright, but again, this needs to be by itself, which means I have to get rid of my 2. So that means I'm going to divide by 2 on both sides. So I get tangent squared x equals 2 divided by 2, which is 1. Alright, now I still have to get this tangent x by itself. I have to get rid of this squared. Well, the way you undo square is you take the square root. So I'm going to take the square root of both sides. So I get tangent of x equals 1. Alright, now I'm at that final point right here where I have just tangent of x, which means I have to do inverse. So that means x equals the inverse tangent of 1. So what I want to ask myself is, where does tangent equal 1? Alright, so I look at my chart and tangent equals 1 at 45 degrees. So that is my first answer. Alright, but if we go back and look, we have to know where else is tangent going to be positive. So A, smart, trig, class, tangent is positive in the first quadrant, tangent is positive in the third quadrant. So my question is, what was the third quadrant value? Well, the third quadrant value with 45 degrees as a reference angle was 225 degrees. So these are my first two answers, 45 and 225. But I still have to take my first answer, plus or minus. This time I'm going to do 180n because my period for tangent is negative 180 to 180, not negative 360 to 360. Alright, so then I also take my second answer of 225, plus or minus, again, 180n. So these are all of my possible values. And let's take a look at one more together. This one says solve 3 sine x minus 2 equals 5 sine x minus 1. Now this looks like a lot crazier because I have more sine functions in there, but we're treating this just like we would a normal equation. Let's pretend like this said 3x instead of 3 sine x, and this said 5x instead of 5 sine x. I have to put my like terms together. Alright, so in order to get this 3 sine x to the other side, I would subtract 3 sine x on both sides. So that gives me negative 2 equals 2 sine x minus 1. Alright, then this right here is still what I'm trying to get by itself. So that means I have to add 1 to both sides. So I get negative 1 equals 2 sine x. I'm still trying to get sine of x by itself. So that means I have to get rid of my 2. So I'm going to divide by 2 on both sides. So I get negative 1/2 equals sine x. And now I'm left at that final part where I have just sine of x. And to separate these two things, I have to do inverse trig. So I'm going to say x equals the inverse sine of negative 1/2. Alright, so that means I have to ask myself, where does sine equal negative 1/2? Alright, if you look back at your chart, we have a problem. The problem is everything's positive. I can't have this negative right here. Alright, so what I really want to ask myself is, where does sine equal 1/2? Alright, well, sine equals 1/2 at 30 degrees. This negative is going to come in because I have to look at all 4 quadrants. Remember, A, smart, trig, class. Sine is positive in the first quadrant, sine is positive in the second quadrant, but sine is negative in the third quadrant, and sine is negative in the fourth quadrant. So that means with 30 degrees as my reference angle, what was that a reference angle for in the third and fourth quadrant? Well, in the third quadrant, 30 degrees was a reference angle for 210. And in the fourth quadrant, 30 degrees was a reference angle for 330 degrees. So that meant that sine would be negative 1/2 at 210 and at 330. Alright, and again, when we looked at our domain of a sine curve, we went from negative 360 to positive 360. So that means I'm going to take my first value of 210 plus or minus 360n, and then my second answer, which was 330. So 330 plus or minus 360n. So So these are all of my possible values. All right, now I want you to, on your own, try these two problems. 2 cosine x minus 1 equals 0, and tangent of x equals radical 3. You must try these in order to get full credit on your homework.